Today we're going to be talking about systems of inequalities. So we're continuing with chapter 9. Okay, we've done inequalities, graphing inequalities on the number line, solving inequalities one variable, absolute value equations, absolute value inequalities, graphing two variable inequalities, and today we're going to be graphing systems of inequalities. Okay, we have graphed systems of equations and solved systems of equations where we try to figure out where two lines cross, where they meet, their point of intersection. Here we're going to be talking about the graphs of systems of inequalities, where we're going to be doing shading. So graphing systems of inequalities. Now, before we get into graphing the systems of inequalities, I want to just do a quick review of graphing lines. We graphed some the other day, but I want us to practice also some not in y equal form. So review of graphing lines. So our first example, let's say we want to graph y is equal to -3/5 x plus 2. This is in the nice y equal or slope-intercept form. Okay, we can identify our y-intercept and we can identify our slope. So to graph that one, this is my x-axis, this is my y. My y-intercept is 2. So I'm going to start up here, 1, 2. Okay, let me just jot down y-intercept 2. And my slope is a -3/5. That's the number with the x right here. And anytime it's positive, I go up and to the right. Anytime it's negative, I go down and to the right. So I'm going to go down 3, and I'm going to go right 5. So starting here, I'm going to go down 1, 2, 3, right 1, 2, 3, 4, 5. And then I'm going to connect my line. Okay, so there is my line. So that's the nice ones, okay, where it's again in slope-intercept form. You can identify your slope, you can identify your y-intercept. Sometimes it's not in slope-intercept form, it's in standard form. Okay, and let me just write here, this is slope-intercept form. Okay, and again, that form is y equal mx plus b. So that's what this one is. Let's go through one that's in what we call standard form. So let's say we have 2x plus 3y is equal to 12. Okay, and this is in standard form. Now, when it's in standard form, you can get it into slope-intercept form by solving for y. That's one way to do it. There's another way to do it though. And how you can do that is to find your x and your y-intercepts. So in order to find my x-intercept, I put 0 in for y, okay? So put 0 in for y. So what that's gonna do is I'm gonna get 2x plus 3 times 0 equals 12. Okay, so this is for finding the x-intercept. So I end up with 2x, and what always is going to happen is when I put a 0 here, that term's going to disappear, so it's going to become 0, equals 12, so x is equal to 6. So I know my x-intercept is 6, okay? Now to find my y-intercept, I'm going to put 0 in for x. So basically, Whatever letter you put the 0 in for, that's not the one you're finding. You're finding the one that's left here, okay? So if I'm going to put it in for my x this time, I get 2 times 0 plus 3y equals 12. So I'm going to end up with 3y is equal to 12, so y is equal to 4, okay? So again, here I'm finding my x-intercept. Here I'm finding my y-intercept, okay? So I usually do this not by physically putting 0 in. I use what I call the cover-up method. So if I want to find my x-intercept, that means my y is 0. I'm just going to be using this pen to cover up my y, because when I put 0 in for y, that term's gone. And I'm left with 2x equals 12, which is what I got right here. So I look at this and go, okay, 2x equals 12, so my x-intercept is 6. I would do the same thing for my y-intercept, okay? So if I want to find my y-intercept, that means my x is 0. Now, when you cover up, you want to make sure you don't cover up the sign in front of the y in case it's negative. So I get 3y equals 12, so y equals 12. I'm sorry, 3y equals 12, so y equals 4, which is what I have here. So those are the 2 points that I need to graph. So I'm going to now graph this. My x-intercept is 6, so I need to be able to get out to 6. And my y-intercept is 4. So again, x, y. So my x-intercept is 6. 1, 2, 3, 4, 5, 6. My y-intercept is 4. 1, 2, 3, 4. And then I connect this with my line, and there's my graph. So there is my line, and there's my graph. So I'm going to go through 2 more of these. We're going to not maybe write out all these steps. We're going to just find our x-intercept, and we're going to find our y-intercept and graph it that way. So the whole point of doing it this way is to have it be faster. If you're having trouble doing it this way, you can always get it into this form by just solving for y. Okay, getting it to be y equal. Okay, so let's try 3x minus 5y equals 10. Okay, and for this one, what's going to happen is, well, and I'm actually going to switch this up to make this one a little easier for us to try. Okay, so I'm going to switch this up to a 3x minus 5y equals 15. Let's try this one. So this one, again, we're going to be looking for our x-intercept and our y-intercept. So basically, when I'm looking for my x-intercept, I'm going to cover this up, and I'm going to solve, and I'm going to get 3x is equal to 15. Okay, so again, I get 3x is equal to 15, which means x is 5. Then I'm going to try to find my y-intercept. So I'm going to cover up my x, because my x is going to be 0. Now, again, when I cover up, I don't want to cover up my negative. So when I cover this up, I get negative 5y is equal to 15. Negative 5y is equal to 15. So y is equal to negative 3. Those are my x and my y-intercepts. So I just plot those. Let's see, I need to get to a positive 5. And I need to get to a negative 3. Okay, so here's my x, here's my y. So my x-intercept is 5, 1, 2, 3, 4, 5. My y-intercept is negative 3, 1, 2, 3. And then I'm going to draw my line. Okay, there's my line. So I'm going to try one more nice one, and then I'll give you one kind of like the one I started to write here, where maybe it's not as nice. Now, the reason these are nice is because the 3 goes into 15 nicely, and the 5 goes into 15 nicely. But when I had it as a 10 here, the 3 didn't go into 10 nicely. So I kind of switched it up to make it a little nicer. So let's try another one that's kind of a nice one, okay? So let's say I have 2x minus 4y equals 12, okay? So this is a nice one because 2 goes into 12 nicely and 4 goes into 12 nicely. So when I'm trying to find my x-intercept, again, that means my y would be 0. When I cover this up, I get 2x equals 12. So that means my x is 6, okay? So I'm taking a little shortcut here this time. So I'm not writing out that the 2x is 12 because I know that if 2x is 12, x is 6. And then I'm going to do it with my y, okay? So now I'm going to find my y-intercept by covering up my x. And when I cover this up, I get negative 4y equals 12. So if negative 4y equals 12, y is negative 3. Okay, so that's my x and my y intercept. That's how fast you can do these, okay? I was showing us the steps up here and the one up above. Here, I kind of wrote out the equation, but if you can just do that cover-up method and find it quickly, feel free to do that, okay? Because the whole goal of this is to graph these fast. Okay, so for this one, my x-intercept is 6. 1, 2, 3, 4, 5, 6. My y-intercept is negative 3. 1, 2, 3. Let me extend that down a little more. And then I'm going to connect those 2 points and get my line. Okay, so there's my line. So the reason I'm going through these is because sometimes you see these when we're doing systems of inequalities. And so I want us to be able to quickly be able to graph them because a lot of times they give us ones that are nice. Not always, but most of the time. Now I'm going to go through one that's not as nice. So that's going to be my next example, one where maybe both of these numbers don't nicely go into it. Okay, so let's say for this example, we have 2x minus 3y equals 8. Now 2 goes into 8 nicely, 3 does not go into 8 nicely. Now you can do that work and get a decimal if you want. That is one possibility. But sometimes the rest of your graph are nice points, but you're not going to be seeing it. So what I'm going to do is I'm going to actually find the one that's nice. My x-intercept is nice. So I know that x is equal to 4. So I know I'm going to have an x-intercept at 4. Now, what I like to do is I like to then look at the slope. Okay. And now for the slope, you can get this to be in y equal form, but you can think about what you would do to get it in y equal form. And what you care about is going to be this number in front of your x, right? So we need to get it in y equal form. So in order to get it into y equal form, again, I'm doing this in my head, I'm not writing it out. What I'm going to do is I'm going to subtract 2x. So this is what I think. Okay, I'm subtracting 2x. So I'm going to have a negative 2 in front of my x when it's on the other side. And then I'm going to divide by negative 3. So my slope is 2/3. So again, what did I do? In my head, I am getting this into y equal form. I'm minusing 2x, and then I'm dividing by negative 3. And I don't really care what happens to this because that would be my y-intercept, and I know it's not going to be nice. It's going to be 8 divided by negative 3, okay, because that's what I would have had to work out. I care about my slope. So again, I'm focusing on this x when I get it over here. So first thing I would do is minus 2x. So that's why I put a minus 2. And then I'm going to divide by negative 3. And that's my slope. So now I'm going to graph this. So my x-intercept is 4. 1, 2, 3, 4. And then my slope is 2/3. So again, this is up 2, right 3. So I'm going to go up 2, right 1, 2, 3. Now you can see I'm kind of off the graph here. So instead of going up and right, I'm going to go down 2 and left 3. And you can keep doing that if you want. Down 2 and left 1, 2, 3. And you see when I connect this, I'm not going to get really a nice y-intercept because it was going to be this negative 3y equals 8, negative 8/3. Okay, so let me draw my line. Okay, now there's my line. Now, this is just kind of preparing us for what really our main lesson is. I just want to make sure everyone's comfortable graphing lines before we get into doing the systems of inequalities. So now we're going to practice doing systems of inequalities. So to graph a system of inequalities, what's basically going to happen is you're going to have inequalities like we had in our last set of notes, where we're graphing a line and shading above or below. But now we're going to have more than one of them, okay? So to graph a system of inequalities, graph each inequality and where they share shading, that is your answer. So I like to do this in two different colors. I'm going to shade one inequality in one color and the other inequality in the other color. And where I have the overlap, that's going to be my answer. So I'm going to start us off with an example. I'm going to do a nice one that's in y form. Y greater than 3x plus 6, y less than negative 2x minus 3. So we're going to be graphing both of these. So the same rules apply that did the other day. There's no line underneath, so this is going to be dashed. This is greater than, so we're going to shade above. This one here, there's no line underneath, so it is dashed. And it's less than, so we're going to shade below. Okay, so I'm going to graph both of these. So I'm going to do it over here. Okay, so for this one, I need to get up to 6. 1, 2, 3, 4, 5, 6. And then I'm going to be going up 3 over 1. Now, since I'm going up 3, 1, 2, 3 over 1, I can do that. It's going to be kind of off my graph. So I'm going to do the opposite. 1, 2, 3, backwards 1. 1, 2, 3, backwards 1. 1, 2, 3, backwards 1. And then I'm going to draw that as a dashed line. So that is my dashed line. And I put a little dot here just so I'm going to color code, okay? And again, for this one, I'm going to be shading shading above. So I'm going to use color pencils. I like to use color pencils when I'm doing that. And so I'm going to be shading above. Okay, so that would be the answer to the first inequality. That makes the first inequality true. I want to be making both of them true. So now we're going to graph the second one. I'm going to start at negative 3. 1, 2, 3. Wow, I just barely made this graph big enough, huh? And then I'm going to be going down 2 over 1, okay? Or I can go backwards, up 2, backwards 1, up 2, backwards 1, up 2, backwards 1, and so forth. And then I'm going to draw that line. So again, that one was a dashed line, okay? And again, I'm color coding it here. And this one I need to shade below. So I am going to take this line and I'm going to shade below it. Now, when I shade below it, what you'll notice is this section here makes the first inequality true. This section here makes the second inequality true. Okay, so again, this one made the first one true, the blue one. This one made the second one true. Over here, what you'll notice is I have blue and I have red. This is where your answer is. So I like to label it answer. This is where my answer is. This section right here where both of them are. So you can shade it in one color for one, in the other color for the second one, and where you have both colors, that is your answer. Now, really, my final answer is really just this right here where both of them are. This does not make the red one true. This does not make the blue one true. This over here makes nothing true. This is your answer, okay? Okay, so I'm going to try another example, okay? So let's say we have y is less than or equal to a negative 1/3 x plus 5. And we have y is greater than a negative x plus 1. Okay, so again, just real quick, this is going to be solid. And since it's less than, I'm going to shade below. So solid, and I'll say below. Okay, just to shorten it. Here, this one does not have the little equal, so it's going to be dashed. And it's greater than, so I'm going to shade above. Okay. So let's draw this one. I'll do it over here. This is going to be my X. Okay. So for this, what we're going to do, we're going to graph this one. So my y-intercept is 5, 1, 2, 3, 4, 5. And my slope is a negative 1/3. I'm going to be going down 1 to the right 3. Down 1 to the right 3. Okay. And let me just get a little bit more on this side. So up 1, backwards 3, up 1, backwards 3. And that's going to be a solid line. Okay, so there's my solid line, and let me put that dot just to color code. So for this one, I want to shade below. So I'm going to be shading everything here. Okay, I like to sometimes, especially when you're starting to learn these, just focus on one inequality at a time, graph that line, and then do your shading. Get it all done so you're done with that piece, okay? And then focus on the next piece. So now my y-intercept is 1. My slope is a negative 1. So that means I'm going to go down 1, over 1, down 1, over 1, down 1, over 1. And I'm just going to keep doing that. And let me continue going here. Okay, and then I'm going to connect that, and that's going to be a dash line. Okay, so there's my dash line, and let me get that color coded. So this one I want to shade above this orange line. So I'm going to be shading here. Okay, everything above like this. Now, when you do this, you will be getting kind of 4 areas, 4 regions, okay? One region, yeah, let me just kind of shade this a little bit more. This was my green one. Okay, it was everything over here. So my green was everything here. Okay, my orange is everything here. So you'll notice that this section here is just green. This is not going to be an answer. Up here, there's a little bit of nothing here. That's not going to be an answer. Over here, this is orange. That's not going to be an answer. Where our answer is going to be is here, because I've got orange and I have my green. Okay, so this is going to be my answer. Okay, let's try one where one of them's not in the nice form maybe. So let's say, for example, we have x plus 2y less than 10 and x plus 2y greater than or equal to 3. Okay? So now, neither one of these is in the nice form, but I can find my x and y intercepts, okay? So let me just get my graph drawn here. And what I want to pay attention to is this is going to be a dashed line. And when it's not in y form, you do have to be careful about deciding if this is a less than or not. We learned that if we multiply or divide by a negative, the inequality direction changes. So whenever we graph these and we're doing our shading, it's always really in relationship to our y by itself. Now to get this y by itself, I would minus x. That doesn't change the direction of my inequality. I would divide by 2. That doesn't change the direction of my inequality. So it's going to remain this direction. So I actually am going to be shading below, but you want to check that first because this is not in y form. So don't assume it's this direction. So in order to graph this, to find my x-intercept, I'm going to cover up my y and I get x equal 10. So I'm going to go out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, a little off my graph. And then I'm going to graph my y-intercept. So if I'm going to cover that up, my y-intercept, it's going to end up being 5. So I'm going to go to 5. 1, 2, 3, 4, 5. And I'm going to connect this with a dashed line. And I'm going to be shading below. Okay, so there's my first graph. That's this graph right here. Okay, and I need to shade below. So I'm going to shade below. Get my pencil. So shade below, I'm going to shade everything below here. And then I'm going to graph the other one. And the other one, again, is not in the nice form. But I can easily find my x-intercept. Okay, when I cover up my y to get my x-intercept, I get x is equal to 3. So I'm going to go to 3, 1, 2, 3. And then to find my y, now 2 doesn't go into 3 nicely, but it's doable math. 2 times what gets me 3? Well, 1.5. If I divide by 2, I end up with a 1.5. So my y-intercept is going to be 1.5. So I'm going to go to 1.5. And then I can connect those. Now, this one here is a dashed line. Sorry, I messed that up, huh? This one should have been my dashed line. This one should have been my solid line. So hold on a sec. Let me just change that. Okay, so sorry about that. I need you guys to keep me honest here. So on this, again, this one did not have the equal. So this is a dashed line. So here's my dashed line. It's dashed now magically, huh? And this one here is a solid line. Okay, so my red one's my solid. And then again, before I just jump to the conclusion that this is greater than, if it's not in y form, you need to check. Minusing x, dividing by a 2, that's not going to change the direction of my inequality. So this is going to be above. And so I'm going to be shading above. So I'm going to be shading above this red line. So when I shade above this red line, now in this case, you see that these are parallel lines. Okay. Now what happens is down here only makes the blue one true. Up here only makes the red one true. And here, both of them are true. So my answer is everything in between here. That's going to be my answer. Okay. Now let me go through one more like this. So let's say, for example, we have something like this. I'll put this one in y form for us. Y is greater than 3/4 x plus 2. and y is less than or equal to 3/4 x minus 3. Let's see how I do on my dashed and solid lines. So this one should be dashed. And this is in y form, so I can look at my inequality. Since it's greater, I'm going to shade above. This one has the equal underneath, so that's going to be solid. And this one, again, it's in y form, so I can look, and this is going to be less than, so I'm going to shade below. Now you'll notice that the slopes are the same. These are going to be parallel lines, kind of like the problem above. So let's take a look at what happens here. Okay, I'm going to graph this one over here. Got some space for it. Okay, so the first one, my y-intercept is 2. My slope is a positive 3/4, so I'm going to go up 3, right 4. Up 1, 2, 3, right 1, 2, 3, 4. Okay, and I'm just going to also maybe get a point this direction. So since I went up 3, right 4, let me go backwards, down 3, left 4. And then I'm going to connect those with a dash. Okay, there's my dashed line, and now I'm going to shade above. So I'm going to shade everything here. Okay, and now to my, and let me just let me color code. Okay, that's my green one. Then my other one is y-intercept at -3, so 1, 2, 3. And again, it's the same slope. So I'm going to go up 1, 2, 3 over 1, 2, 3, 4. And again, let me go backwards. So down 1, 2, 3, left 1, 2, 3, 4. And this time, this is going to be a solid line. Okay, so there's my solid line. And there is my color code. Okay, so this time I want to shade below this one. So to shade below this one, I'm going to be shading here. Now I wanted to go through one like this because sometimes you have this happen. The green is true up here. Nothing is true here. The purple is true down here. This one has no solution. Okay, so this one, no solution. There's nothing that they both share. Okay, this makes green true. This makes nothing true. This makes purple true. No solution. That's your answer. Okay, and I want to go through one last one. I want to do one where it is in standard form, okay? But maybe we have to switch our inequality direction. So 2x minus y less than or equal to 4, and -3x minus 2y greater than 6, okay? So we can decide whether or not it's going to be solid or dashed, okay? This one's going to be solid. This one's going to be dashed. Now, what's going to happen with this one is when I try to get this in y form, and again, I'm not physically getting y form, I'm thinking about getting in y form. I'm going to be minusing 2x. That does not change the direction of my inequality. But then I'm going to have to divide by a negative. That's going to switch the direction of my inequality. This one here, I'm going to add 3x. That doesn't switch the direction of my inequality, but I'm going to have to divide by a negative too. Why? That's going to switch the direction of my inequality. So the ones you need to pay attention to is the negative in front of your y. That's where you're going to have to switch the direction of your inequality. Having a negative in front of my x does not. If this is a negative, I'm going to add it. That doesn't switch it. Only if it's a negative in front of your y will you have to change the direction of your inequality, because you're going to divide by a negative. So what I'm going to do is I'm going to list my x-intercepts, and well, I'm not going to list them, I'm actually going to graph them, okay? So let's put the graph over here. Okay, and I'm going to graph my x and y intercepts. So for the first one here, okay, if I'm focusing on this and I cover this up, I get 2x is equal to 4, so x is 2. Then when I'm trying to get my y-intercept, that means my x is 0, so I cover that up, and I get negative y is equal to 4, so be careful. That means y is negative 4. 1, 2, 3, 4. I'm living on the edge this video, huh? My graphs are close to the edge. Okay, next one. On this one, again, I'm going to find my x-intercept, so my y is 0. I get negative 3x equals 6. So that means x is equal to negative 2. Okay, now actually before I do that, let me actually draw my line. I'm jumping ahead. Okay, so drew that as a solid line. And again, we were deciding if we're going to be shading above or below. Because of this negative here, this negative in front is going to be really changing the direction of this inequality. So this is going to be above. And again, the reason it's above is because that negative in front of the y, when I get this to be in y form, I'd have to divide by a negative, and that switches the direction of my inequality. This negative down here, negative 2, when I divide by negative 2 to get my y by itself, it's going to switch the direction of my inequality. So this is going to be below. So both of these switched in this case. Anytime your y has a negative, your inequality is going to switch. So this one was going to be solid and above. Okay, again, it looked like originally it's going to be not above, but when I isolated my y, it is. So I'm going to shade everything here. Okay, now this one, my x is going to be a negative 2 when I cover that up. So I go to negative 2. My y is going to be a negative 3. So I'm going to go down to negative 3. 1, 2, 3. I'm going to be connecting this with a dashed line. So there's my dashed line, and I'm doing this one red, okay? And I need to shade below this line. So when I shade below, I would be shading this little section here, okay? And I'd be shading all of this over here. So you see, this part is just red. That would be just this inequality. This part is nothing. It doesn't satisfy either inequality. This part here would be my blue one. This part here, again, I'm shading all of my red, and my blue I'm supposed to shade above. Okay, so over here, this is where I have both. So this is going to be my answer. And that's the end of our notes for today.